Let's do it. Let's go, guys. Jeremy, kick it off. What are we discussing this part of the tutorial, man?
Perfect. So, getting towards the end of the project, we are going to do confidence intervals and then prediction intervals, just to kind of, for lack of a better word, validate my entire project. So we're going to run. Let's see. We will run all of this for run scored. Let's see. Get a command copy going. Okay. So this code in here, we've got the model, the summary, and then we're going to try to get a critical value, as well as producing a confidence interval. And I have done that again. You will have to forgive me. Using the objects to call the variables. It's really important. Okay, so we've got the summary of our model, without fielding percentage this time. Good estimates, not too high. And then we use this line of code right here to get a critical value. The critical value is the number that we can plug into our confidence interval formula, which is just for one side of the confidence interval. It's the estimate minus the critical value times the, what is that third number? Should be standard error. Yeah, right here. So standard error. So it's our estimate, which is 0.07575 times the critical value, which we will calculate, minus the critical value times the standard error, which gives us this 0.106 on one side, and then the other side is 0.044. So just looking at my PDF, you see right here, this is our confidence interval. So this simply means that we're 95% confident that the true run scored slope parameter is within this said interval. And our run scored slope parameter is right here. And so then we can do the same thing for ERA.
Slow down a little bit.
Yeah.
So you said run scored is what again?
Yeah.
What?
So we have, confidence intervals are nice because they allow us to kind of see where our parameters lie. And so we want to be able to create a confidence interval that has, when you run this project again, with using, like a different season's data or different compiled seasons data, you want the data to be able to, or you want your run scored slope parameter, which is this estimate right here. The estimate's the same thing as the slope parameter. You want your parameter to fall in this interval every time you run a project. So we used MLB data from the 2016 season, and it gave us a slope parameter of 0.0575. But if somebody wanted to go and use, the 2014 season data, we're 95% confident that the slope parameter would hopefully lie within this confidence interval.
So the slope, the R squared, needs to be within that interval, and if it is, then what we're working on is valid.
Right.
And how did you get that interval?
Yeah. So the interval equation, it's slightly difficult to see with this right here, but it's essentially the slope parameter or the estimate, which comes from the summary of the model.
From the intercept or the data RS?
Yeah. So data RS.
Okay.
It's the slope parameter minus the critical value, which we have to calculate.
Yeah.
And I'll get into the calculation for that in a second.
Yep.
Critical value times the standard error, or standard deviation. In this case, it's standard error since we're just taking it from the model. But to calculate the critical value, so there's this function in R called Qt, which is a formula to call the critical value. And then as far as the rest of it, 0.025. So we're calculating a 95% confidence interval, which means, so if you remember earlier when we talked about the F-test and we were just using one tail, in this case we're using two tails of the distribution. And so
is that the front and the back, or the beginning and end tail essentially? What do you mean?
What's that?
Describe. Okay, I get it. We'll talk about tails later.
Yeah. And so essentially, if you have a bell curve, you have 95%, which is the. Let me pull up a bell curve. That'll just be
there we go. Now you're thinking on your toes.
So this is essentially what a bell curve looks like.
Yep.
Um,
You can go to the one with the percentages down there. Yep, that's the one.
here's a perfect one.
So
0.25. If you look at you look at this 13.5, 34, 34, and 13.5, that adds up to 95%. And so we're confident that 95% of the runs scored slope parameters are going to end up in here. And so on the outside, this is our what we consider our tails. So with this line to the left and this line to the right, you'll see 2.5% and 2.5%, which when you convert that to a number, it's just 0.025.
Yep, very good.
Which is where this comes from.
Yep.
And so you have just one of the tails, 0.025. And then you can also, if you don't look at a bell curve, you can also just get that from doing 1 minus 0.95 divided by 2. So that'll also give you 0.25, 0.025. And then the 27 just comes from the degrees of freedom. Or not that one, sorry. This one. This degrees of freedom right here. And so that's how that gets plugged in. And so that critical value spits out a number. I didn't ask the code to spit it out specifically. I just asked it to, I stored it as the object crit val, and then plugged it right into the confidence interval formula.
Okay, cool. And then the confidence, we got 0.16.
Yeah, so the confidence interval ranges from 0.044 to 0.1. And then you can see that our slope parameter does lie within that. And then if somebody wants to go do future projects, we would hope that that their run scored slope parameter would run or would be within this confidence.
So we're 95% confident that 80% of the time we'll be able to predict. What was the linear model? It said 80%. How did we get? We got to 80%, right?
80%, yeah.
So 95% confident, 80% of the time, like what we predict as far as the run score, will predict the winner of this game, right?
Right. Cool. And so we can do the same thing for ERA.
Yep.
What's that?
I said yep.
Yeah. So do the same thing for ERA. We'll just copy that right over. Yep. We won't need to reproduce the model or anything because the critical value is going to stay the same. And so when we run that, we get a confidence interval that goes from roughly negative 13 to negative 21. And then we can see that our estimate lies within that. And then the same thing goes when the other people would run future projects, you would hope that the slope parameter for ERA runs within this interval as well.
Very good. Very good. And that is for the confidence.
Yeah, that was for confidence intervals.
What do you want? You can just go to prediction. It's not that long.
Okay. And so next we want to do
prediction interval for
prediction
average.
Intervals. Yeah, for average run scored and average.
Yeah, all right. Let's see it.
So we're gonna do 95%. It's pretty standard across R. And so first I will get this for you all. And so we're going to need, just so we know that the means of the means of each of the variables, since that's what we're predicting on is the mean.
Okay.
So the mean run scored of our data set is 724.8 over the course of the season, and the mean ERA is 4.18.
724 wins. Okay, very good.
The 724 runs scored, 4.18 ERA over the course of the year. Okay, so this is our function, and then the formula within inside it. So we're using mod.3, which is what we chose to be as our final model right here. And then we've got the frame that we're using is the mean of run scored, which I went ahead and just did those earlier so that you guys could see what it was. But using mean of run scored and mean of ERA. So let me change this so that we don't get another error. Okay, and then the interval, we're doing a prediction interval. So that's why I believe you can do different intervals, but this just to specify, and then the level is at 0.95 because we want to do a 95% prediction interval. Did I miss a? I did. I missed a closing parenthesis. And so when we run this, we have an error because that's not very fun. Let's see, X. Unexpected equal sign. In
Go back.
this. Unexpected equals.
But yeah, so at a high level, this information will predict what again?
This will predict. This will give us like another interval, and so in this case, it produces the interval 70.8 to 90.9. So essentially means we're 95% confident that the true number of wins lies between this interval when you score 724.8 runs, well, 724 runs, and have
about
4.1.
Will be about 81 wins. Banger.
And it about 81 wins.
Good job. All right.
So,
I'm
not sure what's going on with this error, but
we're gonna stop the video there.